All right, today we're diving into something truly mind-blowing in the world of cancer treatment. We're talking about how we can actually use a focused beam of radiation not just to kill a tumor, but to light a spark that ignites the body's own immune system into a full-on cancer-hunting machine. But to really get how this incredible alliance works, we've got to start with a really weird medical puzzle.
So let's picture this, right? A patient has cancer and it's spread. Doctors zap just one tumor, let's say in the lung. And then something totally unexpected happens. Another tumor, way over in the liver, one they didn't even touch, starts to shrink. Sometimes it just disappears. I mean, how on earth is that possible?
Well, this crazy long-distance effect, it actually has a name. And for the longest time, doctors just saw it as this weird fluke, super rare, totally unpredictable. But figuring out why it happens, that has completely changed the game in cancer therapy.
It's called the abscopal effect. Kind of sounds fancy, but it just comes from the Latin for away from the target, which is, that's perfect, right? You treat one spot and you see an effect somewhere else entirely. And like I said, this used to be super, super rare, almost like a medical ghost story. But the cool thing is, now we know what's really going on behind the curtain.
Okay, so this is how it all goes down. When radiation blasts a tumor, those dying cancer cells, they don't just poof out of existence. Nope, they basically explode. And when they do, they release all these alarm signals and these little things called antigens. You can just think of them as enemy flags. That's the signal. That's when your immune system wakes up. These scout cells show up, grab those enemy flags, and they race off to your immune headquarters, your lymph nodes. And there, they train an entire army of soldier cells, teaching them exactly what that enemy flag looks like. Then, this brand new army is unleashed into your body to hunt down and destroy any other cancer cell carrying that same flag.
So get this, the thing that's actually doing the long-distance killing isn't the radiation beam. Not at all. It's your body's own secret weapon, your immune system. The radiation, that was just the alarm clock.
And this is such a great way to think about it. We used to see radiation as just a local weapon, right? A demolition crew. But it's so much more than that. It's a flare gun. It's not just knocking down the building, it's lighting up the sky for everyone to see, basically shouting, "Hey, the bad guys are right here!"
So, let's meet the crew. First up, you've got your dendritic cells. These guys are the scouts, the intel gatherers. Their whole job is to swoop in, gobble up the debris from the zapped tumor, figure out what the enemy looks like, and then present that intel to the rest of the immune system so it can plan the attack.
And who do they train? They train these guys, the cytotoxic T cells. These are your elite soldiers, your special forces. As soon as they get the briefing from the dendritic cells, they are laser-focused on one mission: find and eliminate any cell in the body that has that enemy flag, no matter where it's hiding.
Okay, but here's where it gets a little more complicated. Turns out, not all tumors look the same to the immune system. You've got hot tumors, which are already packed with T cells. They're basically a war zone, ready for a fight. But then you have cold tumors. These are like an immune desert. There are no soldiers around. The tumor is basically invisible to the immune patrols.
And this whole hot versus cold thing brings up a really important question. If we have this amazing internal army, why doesn't it just work all the time? Well, the answer is that cancer is smart. It doesn't just play defense, it has its own tricks. It's a master of disguise.
Yeah, this is really the big question, isn't it? We have the scouts, we have the soldiers, we can identify the enemy, so why does cancer still win so often? It's because it's not just sitting there, it's actively and very cleverly fighting back.
And to get how it does that, we have to talk about something called immune checkpoints. Now, these are actually a good thing, a totally normal part of your body. They're basically safety brakes for your immune system. Their job is to make sure your T cells don't go crazy and start attacking your healthy cells, to prevent friendly fire.
But, and here's the clever part, cancer learns how to use this system against us. The tumor cells can actually put proteins on their own surface that slam on those brakes for any T cell that gets close. It's like they throw on an invisibility cloak and tell the soldiers, "Hey, I'm a friend, nothing to see here, move along." And these are the two main brake pedals that cancer has figured out how to stomp on. You've got PD-1, PD-L1, which is basically a direct off switch on the T cell itself. Then there's CTLA-4, which works earlier, kind of gumming up the works back at T cell training camp. For a long time, this was a massive problem. But now, and this is the exciting part, we have these amazing drugs that can block these signals. They essentially cut the brake lines, freeing up the T cells to go on the attack.
So this is where it all clicks into place. What if you could do both things at once? What if you use the radiation as the flare gun to reveal the enemy and use these new drugs to release the brakes on your army? Well, that's the whole beautiful idea behind radioimmunotherapy.
It's this incredibly powerful 1-2 punch. The radiation exposes the enemy, ripping off its invisibility cloak, and at the exact same time, the immunotherapy takes the brakes off the T cells, letting them go full throttle. One part of the treatment makes the enemy visible, the other unleashes your body's own heroes to take it down.
You know, scientists have a really cool term for this. They say the radiation creates an in situ vaccine. In situ just means on site or in its original place. So instead of making a vaccine in a lab, we're basically tricking the tumor into becoming its own vaccine, right there inside the body. It teaches the immune system what to fight, from the inside out. It's brilliant.
And just look at the difference this makes. It's huge. Remember how we said that abscopal effect, that long-distance killing, was super rare, a medical fluke? Well, that's what you see with radiation alone. It's a tiny sliver. But when you add immunotherapy to the mix, boom, you take that rare event and you make it the main event. You're not hoping for magic anymore, you're making it happen.
And we're not even done yet. This is just the beginning. Scientists are constantly finding even smarter, more powerful ways to boost this effect, layering different strategies together for a full-on assault.
So, for example, let's talk about macrophages. Think of them as the police force on the scene. Now, tumors can actually bribe these cops, turning them into what we call M2 macrophages. They basically start protecting the tumor. But what's amazing is that radiation can help flip them back. It turns them into M1 macrophages, the good cops, who then start attacking the tumor and calling for T-cell reinforcements. And the radiation itself is getting way more advanced too. We have techniques now like SBRT, which is basically like upgrading from a shotgun to a high-powered sniper rifle that is also a flare gun. It delivers a massive, super precise dose that not only obliterates the tumor cells, but also sends out the biggest, loudest alarm signal you can imagine to the immune system.
So the ultimate strategy, really, is like tuning a performance race car. The radiation, that's the fuel. It creates the targets. The checkpoint inhibitor drugs, they release the brakes, getting the car rolling. But now, we're even adding an accelerator. These new drugs, called co-stimulators, literally slam the gas pedal down on the T cells, making their attack way faster, way stronger, and longer lasting. Which really just leaves us with this incredible thought for the future. We know how to use radiation as the spark, and immunotherapy as the fuel. So the big question now is, what other brakes and accelerators are hiding in our immune system? What other dials can we turn to perfectly tune our own bodies to win this fight?